I did all three, two of them for Caltech, and then one when I was at University of Pennsylvania. And you can see the cars were evolving over time as the events happened. The first one was very much just hack a Chevy Tahoe, a more professional Ford van, and then a Prius, which was minimally modified. But it's been fun to start off at a very, very crude level and work my way up. My personal history, I started on the first vehicle, I was doing purely mechanical things. On the second one, I was doing low-level embedded programming, and then on the third one, I was doing full-stack programming. After school, I came out to Silicon Valley in California and joined Willow Garage. And there, I started working on ROS and the PR2. The PR2 is a humanoid robot, 2 arms, wheeled base. It was designed to be the main a main platform for research and development to help people facilitate collaboration between universities. And it was also the proving grounds for the development of ROS. When I was there, the PR2 price tag was something like $400,000, which is not very accessible. But open source software is supposed to be successful. And so one of the things that when I was there, people would complain like, oh, I can't use ROS because I don't have a $400,000 robot. And that's not true. And to prove this, we created the TurtleBot, which was an iRobot Create, a netbook. This was back in the era of netbooks, and the Xbox Connect that had just come out. And so with that, you can put those together. We had open source designs for the parts that you needed to glue those pieces together. And you had a TurtleBot that you could learn and access for, access ROS and learn how to use it for a very accessible price. In 2013, I transitioned to Open Robotics to keep maintaining ROS and friends, and I've been there ever since. Give me a little bit more about Open Robotics. Established in 2012. I'm actually going to be going back to California. We're celebrating our 10th anniversary party next week, which is going to be a lot of fun. We're about 50 people spread all around the world. Our main office is in Mountain View, as well as we have people throughout the US, including a focus in Boston, Europe, Japan, and we have a Singapore office, which is our second largest group. And we do many more things besides just ROS. ROS is one of the core offerings we do, but we also are the force behind Gazebo. It's a physics-based simulator. Many of you in the PX4 community are familiar with it because it's fully integrated into the PX4 process. And our goal with that is to be able to provide both ROS, which is the framework that can glue things together, and then Gazebo is a physics-based world where you can test and validate all your software without having to incur the cost of real hardware, such as batteries, crashes, etc. You can do a lot. Failures in simulation are very cheap. You can just put reset and everything's fixed. The latest version of ROS has come out as Humble Hawksbill. Kat gave an overview of that yesterday here. And the latest version of Gazebo is Fortress, with Garden coming out very soon, I believe. To give you a sense of scale, we count on the order of 100 to 200,000 users per month downloading software from us. It comes out to a total of almost 1.5 million users per year. In this case, users is not clear whether it's robots or people, but we're roboticists, so do we care? But we've considered to have year-over-year growth, giving us nice exponential growth rates for the 10 years that the project's been running, or 10 years that the company's been up, and before that, the project all the way back to 2008, which means that we have some pretty impressive numbers. You have this map, shows you a heat map of where we have people accessing our services. The US is 19%, China is just a little bit ahead. But all of these numbers that I'm presenting are based on access to our main servers. We have lots of mirrors and proxies, and we encourage people to set those up for faster access locally. And we don't have any statistics from them because that's the nature of open source. Give you a little bit of the history. The first commit to ROS was on SourceForge November 7th in 2007. We did this because at Willow Garage, we were like, we're going to do this open source, we're going to do it right. And where do open source projects go? They go to SourceForge. And so the primary repositories for all of the work at Willow Garage started out on SourceForge. This turned out to be not great, and we had to move away because we actually got to the point that our commits to SourceForge started getting slow. And when we complained to them, they actually told us, oh, you're 50% of our volume of commits in the entirety of SourceForge, at which point we started self-hosting. The first paper on ROS was a conference, a workshop at ICRA in 2009. This is pretty cool. We're approaching 10,000 citations on that paper, expected to come up in the next, I expect it to happen within this year. Jumping ahead, there's some other things, but the other one I really want to point out is that we have a new paper in the Science Robotics Journal that came out this spring. So if you're looking for information, a summary of ROS 2, that's a great place to go look and cite. And the other really cool thing is that Arturian was one of our case studies in that project. So there's really good representation of the drone community there. So looking at what we're doing at Open Robotics, we're doing open source. We work with the community members, companies, etc., to make sure that all the features are there that they want in a robot. So they can build a robotic system and make it happen, gluing together open source products. Our vision for creating ROS was to be the lamp stack. The lamp stack was the thing that helped the internet industry take off because you had a bunch of open source parts that you could put together and then create your application almost overnight, but that's because you're building on the backs of a lot of other people that have put together those functionality that you can use. And we've worked hard to do this with ROS, and a case study that we have from Simbe Robotics out in Silicon Valley is Tully. You can see it on the right here. In 18 months, they got to the proof of concept vehicle that they could drive around and demonstrate to investors. And they went back and looked at how much software they were using, including all the parts of ROS that they pulled in. And to reproduce that software, they estimated it would take them 22 years of developer time. And so in 18 months, 3 people were able to produce a minimum viable product versus 3 people that would have been like 6 or 7 years of full-time work. And with that, you can get better product, faster, sooner to market. All of these are very valuable to companies and also individuals that want to do cool things. And so thinking about the lamp stack, we want to think about like how do we put that together, and we break it ROS down into 4 major components. Unfortunately, it's a highly overloaded term. Robot operating system. Everyone asks, well, what are you, an operating system? And we're not an computer operating system. We would look to be more of a robot operating system, giving you the fundamentals that you use to make a robot work. And those fundamentals, we start with plumbing. That's the sort of core build tools, inter-process messaging, etc. These are the things that help you make things happen. But on top of that, there's a whole lot of tools that are actually tools that you're going to use. Things like 3D visualizers, logging and debugging, and introspection tools that help you understand what's happening. And this is how we make the developers more effective. And then on top of that, there's also capabilities. These are things like the 2 primary ones that I like to point to are the navigation stack and the Move It community, or the Move It library. Basically, these are functionality. If you want to do 2D navigation on a plane, pick up the nav stack, parameterize it for your robot, and you can basically plug and play and go. Similarly, if you want to do motion planning, I highly recommend checking out Move It. It's optimized and main focuses on articulated arms, but it'll work for any planning envelope that you want to be planning through. And then the other thing that we've been enabling with all this putting together is the ecosystem. There are thousands of ROS packages out there doing tons of different things for many different communities. And we work hard to work with the community to release them, to make them available, to index them, so that you can just simply go and download them, parameterize them how you want. The ROS 2 enhanced capabilities I'm going to come back to in a little bit. But just back to Open Robotics now. We are 50 people, and we keep ourselves going but through doing consulting with people like you, companies like you. We are stewards of ROS and Gazebo and make that happen often in the overhead and the profits that we get from doing contracting with companies. What we look to do is find companies that are doing things and building products and look for the pre-competitive items that we can help support them to make their product come to market faster or sooner, but is not part of what they will be differentiating. So if you need a new feature in the communication protocol or a new functionality, we'll work with you to help you make that happen. We do this with companies from startups all the way up to Fortune 500s. And our goal is to basically help you get to product faster and more efficiently. Some of the people we've worked with recently are listed here. And the other thing we have is the ROS Technical Steering Committee. So if you are part of the community and you're putting in at least one full-time developer into the ROS community, ROS development of core modules, we invite you to come apply to be on the Technical Steering Committee and help us guide the direction of ROS. We've done this a little differently than Linux Foundation, where we're looking to have people actually be contributing, not necessarily just not a buy-in. And so I mentioned ROS, and we got it into academia. That was our main focus originally at Willow Garage. We had the PR2 as a research platform, but since then we've slowly spread out into all realms. We have water, land, air, and space. Calling out a little bit of what's going on in the land space, you can even focus in on more specific industries, and there's a whole lot of examples here. These are some examples from agriculture. We can also do material transport. This is one of the ones that has the largest adoption of ROS because it's a nicely constrained area, and all the systems are very, very similar. But a lot of those companies that I called out there are all using ROS 1. And that perfectly makes sense. I think that the big thing that we've identified is almost all of those companies were people that came out of research and are comfortable with ROS 1 and created startups that started using ROS 1. However, we realized that with ROS 1, there was a bit of a gap in what we were looking for. And so in 2013, one of the first things Open Robotics did was create a ROS For Products Workshop. We did this in conjunction with NASA, and one of our primary sponsors was Bosch Research, because they came to us and said, we have a problem. We have created an autonomous lawnmower. It runs around, it uses ROS, it does everything it needs to do, and they did this at Bosch Research. And then they're like, yes, we want to make a product out of this. And you can actually see the product here. But the problem is that when Bosch Research took it to Bosch Product and said, here's a prototype, please make it, the first thing that Bosch Product did was throw out everything that Bosch Research had done and start from scratch because they didn't trust ROS 1. And this is not necessarily because it wasn't good enough, it's just they didn't have enough knowledge and visibility into what made it reliable and useful for their applications. And so we did this product workshop with them, and we really focused in on what are the next generation things that we're going to need to be able to support ROS going from research, where we have pretty good saturation, into product. And coming out of that project, we need to be able to support embedded products, we need to support multi-robot, we need to be able to support real-time, and also look at more of the commercial development cycle. One of the things that when Bosch was looking at it was that in ROS 1, our primary focus was we won't wrap your main. You can write your own main and you can do whatever you want and use it however you want, and we'll be super flexible and make it possible for you to do amazing things that nobody's ever thought of before. But it turns out that that is not what a product manager wants. A product manager wants to know that they can hire engineer 1, he will implement it, engineer 2 will come along and iterate on it, and down the line, engineer 100 that comes along 5 years later will still be able to pick it up, use it, and do it reliably. And we needed to actually focus more on providing constraints and best guidance and best practices for the development so that we can have sustainable products that are more, the total cost of maintenance is lower. And so with all of those insights, we have created ROS 2. And I'm happy to say that we've been able to really get some great examples of people that have taken ROS 2 and put it into products. One of them that took a lot of convincing and a lot of these things was iRobot. They started they looked at ROS 1, they used it in some various research platforms, But then they seriously came along and started pushing on ROS 2. They downloaded, they worked on it, and they've joined the community and have been pushing it harder and harder, improving executor models, efficiency, etc., so that they can fit it onto a Roomba. And now, if you buy any of the medium to high-end Roombas, they come with ROS 2 inside. It's really awesome. This is by far our biggest deployment of ROS 2. And that's because we worked hard to make ROS 2 into something that product managers can pick up and trust. And the other cool thing is they've now created the Create 3, which is their hacker DIY learning platform. And its API is actually just a ROS 2 API. So if you want to play with a ROS 2 robot, you can go buy an iRobot Create 3 and play with it. The other case that I'd like to point to is Apex.ai. They're doing autonomous driving, and they picked up ROS 2 and have run with it and actually been able to create a version of it that they've built into what they call their Apex OS, and they have it certified ISO 26262 and up through ASIL level D certification to do autonomous driving based on top of ROS 2. They've forked it and extended it a little bit to be able to push it through the certification process. But this is really cool to see that the baseline that we have is actually able to be pushed through that product certification process. And this was all these sort of refactors, and this is why we came back to look at ROS 2, is we wanted to make sure we could get into these areas. One area that is more relevant to this community is air and space. There's actually a long history of ROS in space. NASA launched ROS to Robonaut 2 on the space station in 2014. If any of you were following, that is ROS Foote is what is running on it, and I believe it is still what is running on it because NASA pushed it through their qualification process and decided that that was safe enough and they could use it. Similarly, in 2019, they've sent up Astrobee, which is a small little robot cube that floats around inside of the space station, helps them with inspection and monitoring. It's a fun little project, and they actually use little fans as thrusters because it operates inside of the space station, which means they can rely on having atmosphere. Both of these using ROS, but the part of what they're doing in this case is that they have gone through and qualified and made sure that the envelope that these robots are operating on cannot be unsafe for the astronauts or the space station, because they were not able to, they did not certify ROS running inside of these things as being inherently safe. We'll come back to that shortly. Another place that ROS is obviously being used in aerospace is PX4. Many of you are familiar with ROS, and there are lots of ROS integrations with PX4. If you've seen some of the presentations, the AI node that Alturian's launched is running ROS by default. And it's integrated with the PX4 through the either MAV-ROS bridge or through the micro-ROS bridge directly. And there's a lot of stuff going on, and the really great thing is that this community can go out and leverage a lot of the tools that were built for general purpose robotics and bring them in. Object recognition, scene recognition, these are all generic robotics tools. They don't need to be necessarily specific for the drone community. Another example I'd like to point to is Elroy Air. Elroy Air is a new startup looking at doing autonomous cargo delivery. The vehicles are large. That tray underneath, I think, is 6 or 8 feet long. So it's full size. Well, it's not small drones that you can carry. But they're actually using ROS 2 and just using the navigation stack that I talked about earlier. So this is a navigation stack. It was designed mostly for indoor navigation. But it turns out indoor navigation actually looks a lot like driving around on a runway and taxiway. And so they can actually use the navigation stack to drive around, and the robot vehicles will actually autonomously drive over and pick up these payload trays, attach them to the bottom, taxi to the end of the runway, and then do the takeoff and landing and autonomously unload at the other end as well. And this is taking advantage of that capability of the navigation stack that they can just use from the greater ROS community. And one place that we're using ROS in space is the Viper project. This is a NASA project looking for volatile chemicals on the moon. And they're looking to, they're using ROS currently on all the ground systems because, again, we're not flight certified. And NASA has very strict requirements for flight certification, and they're already using a bunch of things like CFS with a ROS bridge. Their YAMS is the mission control software that they've chosen, and Verve is another framework that NASA has developed. They want them to be used in flight missions. They have to be space qualified. Well, we're just going to be on the ground at the moment. And so now we need to start thinking about how we actually get to certification. And we've designed ROS 2 to support this process. We have very strong modularity. Well, there's thousands of packages, but if you only need to use one, you just have to trace through your dependencies. And we've done a really focused on making sure that those dependencies are minimal as possible. So you can pick a small slice. So you don't have to try and certify all 1,000 packages. You can pick the 10 or 20 that are of interest to you. We have good abstractions, decoupling independent elements. For example, we've done things like allow nodes to be able to, you can use composition and include different capabilities, but that also means you can exclude them if you don't want to have all those capabilities and have to certify them. We knew that we were looking forward to real-time support, etc., so we made sure that you can do custom allocators because you can't do dynamic allocation inside of any real-time system. And also we've designed things to be pared down. When possible, things like the logging systems are run through macros, so that if you choose to compile, if you don't want to have the logging, you don't want to have to certify the logging and know that it's going to run in real time, you can just compile it out and it will run and not have a problem. Oops, and I got custom allocators on here twice. So looking forward, we have Space ROS, which is, we are working with NASA and Blue Origin, and our goal is to actually have a space certifiable set of packages, such that if you're building a spacecraft, you can just pick up ROS packages and use them from the specific set to build out your system. And this will help us get to the point where we can leverage the open source ecosystem in space systems. For a long time, they do really focus on reusing code, but it's not the full open experience that we'd like to bring to them. And our experience with doing this is actually really valuable. Part of what we want to do is we want to make sure that everything stays open and gets pushed back to the greater community, not just a sort of little small isolated section. We're going to be working towards supporting DO 178C and NPR 7150.2. This will get us up to those standards that NASA is going to want to be able to put things into flight systems in space. And in addition, if we're doing this, there's obviously some things that are valuable to put in that can be shared components. So we'll also be working to build up that library of capabilities that are space specific, say star tracking, terrain navigation, extraterrestrial navigation. Turns out that's not commonly tested with the rest of us. So, got to keep going here. So what are we doing so far? We have a GitHub organization with a core set of packages that we've triaged and said these are the main focuses we're going to be working on. We have continuous integration set up. We have Docker scripts for setting it up, including all the way up through Move It 2 to bring these together and be able to demonstrate them. We're integrating all of the NASA preferred linters and static analyzers, including Cobra and ICOS. And the cool thing is we're taking all of those, we're building this for Space ROS, but we're making that available to the entire ROS community. So you can run all of these tools on any package in the community. Even if you're not trying to go for space certification, you can just use those. And part of this is also, there's a new standard for outputs called Serif, and we're working hard to integrate ICOS and Cobra, but also the existing tools that we've been using throughout the system, such as GCOV and CPP, lint, etc. We want to get those all into the Serif output and be able to generate a dashboard for this. Obviously, we're also going to be looking at reducing and eliminating any dynamic memory usage that might be in there, improving the logging to meet the requirements, and I mentioned the dashboard already. So, high level of this is there's a lot going on. You can find it at github.com/spaceros. But also, if you're interested in being involved in this process, helping drive this process, please reach out to me. We have a set of partners already, but we're always looking to grow it. The more partners, the more requirements we have, the more we can actually tailor and focus this effort. So, with that, definitely love to hear from any of you. I'm going to stop here for a minute to take any questions if anyone has any. Space Ross, anything? Yeah. The DO178C, yeah. Yeah, so the question for online audience is how are we going to integrate the things like DO178C into the open source development process? And basically, our goal is to push back anything and everything we can to the mainline ROS. We want to have the certified version of ROS and the mainline ROS be compatible. And so we will push back as much as we can. And the nice thing is that the DO178C does not require you to do anything behind a firewall. It just requires you to do a lot of extra procedures. And so for the things that we're going to want to push up to this certification level, we're actually going to require, likely going to require the contributors to meet those standards for contributions to these core packages. And it's going to be a very thin slice, but we are going to want to put those requirements on to contributions coming from the community for those core packages. Now, the nice thing is that it's not required necessarily that the community provide that. So if there's a feature that, say, you submit and you haven't done all the qualification to meet the DO178C requirements, I can then pick up your pull request if I think that's valuable and iterate on and extend it, do the extra qualification, and then merge it once I have validated it, and then I can merge it in as the maintainer. Yeah, so the open process is not incompatible with meeting the certification. Basically, to provide the certification, there are extra layers that we need to do to provide the assurance to people that will be using it later. So I'm going to, for the sake of time, I have a whole second section that we're going to be also doing a similar effort for medical certification with the FDA for IEC 62304. Because it turns out most of the requirements are actually overlapping, and we can do the same thing, set up the same processes to be able to support medical devices in addition. And I talk about the business model here. Our goal is that all of the code that is in these certified versions will be open source. And then if you need to go for certification, you're going to need safety documentation. And to provide that safety documentation, there's a lot of overhead and effort. And you can come to us to get that safety certification document. You're welcome to take the open source code and go through the process yourself. But we think it's going to be more efficient for us to be able to produce that safety documents for people to consume down the line and aggregate that effort. So again, I'm not going to pitch the medical ROS here because if anyone's interested, definitely come talk to me. But we got 1 minute for questions. Anything else? Otherwise, feel free to follow up on me afterwards, and thank you for listening.